So in this problem, I have an incline, as you can see, with two masses connected by a string, and this is a pulley. The coefficient of friction is 0. In this instance, a 30-degree angle. Mass 2 is 10 kilograms, and mass 1 is 8 kilograms. So the first thing I did was draw the forces acting on this system, and I now have a normal force is what I put first, and then I had a force of gravity, so mass of this object times gravity, and then I have the components of gravity: m1 cosine theta, m1g cosine theta, m1g sine theta. So at this point, I knew that m1g cosine theta was equal to the normal force, so I made that note here. And on this side, I just had my force of gravity, m2 gravity. So what I'm looking for is my acceleration, the tension 1 and tension 2. And we're going to assume that if it goes this way, it's in a positive direction. So I went ahead and wrote down F net. Yeah, this is Newton's second law. F net equals the mass total times acceleration, and then I converted that to acceleration equals F net divided by mass total, and then for my F net, I took m2g minus m1g sine theta. So I circle these because these are the net forces on this object. And let's see, divided that by the mass 1 plus mass 2. So I plugged in my information and let me with once I algebraically solved this, it gave me 3.27 meters per second. And then for the second part of the problem, which is now finding the tension, I went ahead and did tension 2 first. And so I drew my object, 10 kilograms, which is M2. And I know it has the tension 2 on top, and then the force of gravity pulling down on it. So I used second law again, and I wrote F net equals mass times acceleration, and then F net is m2g minus t2, which equals m2a. And then what do I do from here? I solved for T2. Then I plugged in my information. Oh, this one should have a parenthesis right here. Just looks bad. So that left me with 65.3 newtons. At this point, I started to assume that the tension in T1 should be the same as tension in T2, but I went ahead and solved for it. So T1 equals the mass of 1 times gravity sine theta plus m1 acceleration. So I plugged in all my information, and that gave me 65.4 newtons, which was pretty close to 65.3. And that is my Newton's second law reassessment.